Can you hear me all right? Sounds good. Everyone here? Who knows? Since the schedule is so tight, I'm just going to start. There's well, first of all, thank you for upvoting my talk today. And I tried to cobble together a short presentation at the beginning, but most of the part will be me trying to assemble pieces of code that I know work together in a way that makes more sense for you to understand it. But there's always the fallback of the full working version, so I hope this is not really live coding, more like live copy and pasting, but I think it will help. So what I'm going to talk about is this, among other things. Short disclaimer, I'm currently working as a freelancer for this company, Novation, but that's not the reason I'm giving the talk. It's just that most of their products are pretty awesome, and this one especially is like one of the cheapest devices that gives you some sort of button matrix with colors on it. It costs under 100 euros. Which sounds a lot for a piece of plastic and LEDs, but if you look at what the competitors are doing, or if you try to build this by hand, this is actually relatively cheap. And also it works very reliable, which is a good thing for music instruments, I guess. So what this is technically is really just a field of buttons and LEDs under it. It's not even velocity sensitive. There are versions that measure how hard you press the buttons, but in this case it's just on and off. And that's pretty cool for a lot of musical applications, but I always feel like we are not using alternative input methods enough. And so I always try to come up with interesting ideas what to do with it. So how to talk to this thing? Well, MIDI, obviously. Like every musical instrument. MIDI stands for Musical Instrument Devices Interface. Some of you may have heard a talk about this from me before. How many of you know nothing about MIDI? Okay, a few hands. So the thing about MIDI is that it's really old. MIDI used to be about this. These are DIN plugs, and the year is 1983. That is a long time ago. How many of you here are born after 1983? Yeah. that always scares me a bit. So the year is 1983, and a few vendors of electronic instruments, you know, the synthesizers just became a thing, and synthesizers wanted to be, you know, you want to connect synthesizers together and have them play each other or whatnot. And so this was basically done by a few companies coming together and agreeing on a standard, something that you don't see that often these days, but I mean, probably web standards are pretty close to what was happening here. And interestingly enough, they got out the 1.0 spec, and that's still the relevant document, which is kind of fascinating. What's not so relevant anymore is like on the second page or so, there's electric circuitry, how you should build these plug things to isolate them correctly so that you cannot destroy your instruments when plugging things together. Nowadays, mostly MIDI runs over USB or just internally in software, but the protocol is still used, and the protocol is basically serial data, because back then that was like the simplest thing that would possibly work, and it's really simple. You only have two types of, well, basically it's byte by byte, and you only have two different types of data. One is a command, and one is a data byte. And a data stream on any MIDI interface, regardless of, you know, one of those old plugs or a USB interface, looks like this. You have a command byte, and then data, 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 or maybe just data, data, and then another command byte. And that's the only way how you can chunk commands. Luckily, you don't have to do that yourselves in modern APIs, but that's how it works, basically. So Speaking to this device, let's talk briefly about output, and what you see is already kind of what you do with the WebMIDI API I'm going to talk about as soon as you see the code, but it's basically you're just sending bytes out. Is this readable in the bottom, or is it too small? Okay, so you send one command and then data behind it, and the specific command here is 144, which is node on, and it's really that basic. It's not like there's no abstraction in the WebMIDI API that says, okay, node on is 144. You just have to know that. Obviously, there are libraries that people wrote to make that a little bit easier, but for me, I've been doing MIDI programming for a long time. This feels home. Like this 144, yeah, I know that. The second one is, in this case, it's a node on command. The second one, this is different for different commands. So there are commands for like twisting buttons and stuff. But in this case, it's really just, OK, play a note. And the note here, 24, these are just half tones. If someone knows what how music notation works, these are just half tones. And the 0 is basically the lowest C, and so 24 would probably be something like Z0 or something, C0. And the last one is velocity, so how hard has someone hit a keyboard or pulled a string or something. If we want to talk to the launchpad, things are a little bit different. So the node on command basically switches on one of those LEDs below the buttons. The node is basically the position on the grid, and they did that in a very, I don't know, clever way, I guess, where every row is, so 0 would be top left, and then 16 would be the left in the next row, because if you've seen this, there are actually 9 buttons on the row, so they couldn't use 8 as a divider, so they use 16, and conveniently, since we are talking about 7-bit numbers, they go from 0 to 127, and 8 times 16 is 128, so it just matches up. Perfect. So that's how they chose that, I guess. So the last one is color, and let's talk briefly about colors on this thing, because they are a little bit special. So first of all, we can only have 127 different colors originally, right? Because we only have these 7 bits. So that's a bummer if you want to do RGB LEDs, because then you have to kind of narrow down the color space to get into that. And I actually didn't look at how the larger launchpads do that. But in this case, since this is a cheap hardware, it works a little bit different. In that they are not RGB LEDs that can do the full color spectrum, but they are red-green LEDs. And red and green LEDs are like one of the first types of LEDs invented. They are really, really cheap, and you can get them in this specific combination. Red-green LEDs are a thing. So they're not 2 LEDs per button. This is actually 1, but with combined circuitry for red and green. And if you kind of modulate the intensity of red and green, you get to something like this, which is a weird spectrum between red and green and yellow and amber and orange, somewhere in there. But it's slightly problematic to use all the different colors, especially ones that are close together, if you want to kind of convey meaning, because they are sometimes the calibration on the LEDs is a little bit off, so you have to be careful with that. I really like that phrase in the documentation. Readers who are versed in the manipulation of binary will have worked out. Really like that phrase. So how does input work? As you might think, they just send node ons and node offs. And for in the WebMIDI API, you would connect an event handler to the input ports. I'm going to show you how that works later on. And then the actual thing is like if you press a button, you get a node on event, and if you release a button, you get a node off event, which is not technically correct in the sense that you actually get a node off command. but it is within the spec that you can just send a node on command with velocity 0, because back in the days, you know, microcontrollers were very slow, and so they thought, well, probably it's easier for them to do it that way, and Novation thought, well, this is a cheap microcontroller, let's do it the same way. So you just get these two signals, and 24, I think I checked, it's like the last button on the second row, I guess. So let's talk about Minesweeper. And you all know, who doesn't know what Minesweeper is? Okay, that's good. So there are a few UI challenges if you want to port this to a device like this. This is the actual Minesweeper version I'm using. If you're familiar with Minesweeper, you will notice that it's actually 8 by 8, and I think the original Minesweeper, the small grid, is 9 by 9 or something. But for this case, it's really good because we have 8 by 8 buttons. And the first challenge is this, because like I told you, colors are really hard to distinguish. So if I want to build something where you can actually check how many adjacent mines there are, and that's really important to play Minesweeper, then I need to come up with a mechanism that works better than just displaying colors. So we'll come to that later. The second challenge is, yeah, you have to flag fields for mines, right? And how do you normally do that in Minesweeper? Right-click, correct. So there is no, like, there are buttons. How do I do a right-click? And so, yeah, I could use a key on the keyboard. That's kind of stupid. And my first approach was to simply use one of the extra buttons and make it so that I press it and then press the other thing. But it turns out that it's a little bit, the button is a little bit too unreliable for that to work, and so more often than not, I would press it and then hit it, and then it would reveal the field, and guess what? There's a bomb underneath it, or a mine, and then everything blows up, and I was kind of frustrated by that, so I took another approach and just make it like different, make it so like there are different modes. So yeah, let's go. This will be probably need to realign this a little bit so you can see it. So I do have a camera here for later on. Let's start with, this is way too small. Is this good? So let's start with the very basics of how you would start interacting with the WebMIDI API. By the way, I didn't talk about this. WebMIDI API currently only works in Chromium browsers. There is a team working at Mozilla to implement it. I have no idea what Apple is doing, and I no signals from Microsoft yet, I think. And so, yeah, we're working for the Firefox thing, but Chromium, interestingly enough, also works on Android devices. So you can plug, if you have an Android device where you can actually plug USB devices into it, that actually works with the launchpad as well. It's kind of cool. So the init MIDI function at this point is only called in an onload handler, and then you do navigator request MIDI access, and it's a modern API, so it uses promises. That's promising. Oh, come on. Yeah, it's a cheap shot. So, and then you would, you need to find your MIDI devices. They are just enumerated in some sort of array. It's not a real array as usual when you're dealing with arrays from internal APIs. For some reason, they always come up with new ways of disguising arrays as something else. And you would do a for each on it, and then you can check the name. And that's basically the only way how you can distinguish devices. So this one goes for Launchpad Mini. If you have another Launchpad, you would probably, and you want to use both, you would probably do some sort of regex on that, which is something, for example, we also do for the device I'm working with in my Novation project, because sometimes also Windows tends to kind of enumerate them and say, okay, Launchpad Mini 1, Launchpad Mini 2, even if there's only one connected, and you have to deal with that. And I'm gonna show you the the Minesweeper stuff in a second, but what you notice here is I'm just using global variables because that's the coding style used in the original Minesweeper implementation. That's obviously not how you would want to do that, but for a short demo like this, this is okay. So I'm detecting inputs and outputs, set variables, and then, yeah, I need to init the display. So let's do that. The function is not here, so let's get that. Like I said, copy and paste. There you go. And what this does is it sets a few messages that are also documented in the documentation. So it sends out a reset. B0 is 176, by the way. That's a control change, another type of message. And then I use something to make this LED blink, which is a special mode, a flashing mode that you have to activate. And then I just send two node on messages to set these two LEDs so that you know that they have a special meaning. Let me check. I think I need to change this. No, it's okay. So this is how the web page currently works, and you can play that. Wow, that's rough. But nothing happens right now on the launchpad. So let's go forward. So we init the display. That's fine, but actually it should be blank. Why is that not happening? That's interesting. Maybe display. Something wrong here? No. Ah, wait, right. Because obviously this is not MIDI send node on. That's not defined as well. Let's get that quickly. It's really, really simple. It's just a convenience function that also checks if MIDI is available. Does that work now? No, it doesn't. Why doesn't it give it? Okay. If this goes on like this, again, I'm going to fall back to the full version. And might be worth checking. Might be worth. Ah, yeah, I know. You're right. I get that. I tried to hack it in a way that I didn't have to like monkey patch the original implementation. So, there you go. Blank display. Wonderful. Where did the shadows come from? Interesting. Oh, okay. Anyway. So we have that, and then let's, in the next step, let's add the input handler here. So that's how you add event listener. That's pretty standard stuff. So we just need the MIDI input handler. Let's get that over. It's this one, and there you can see like how this stuff sort of works. So you get a data part in the event, and it just contains an array. It's a typed array of uint8s that will just contain the data sent over. And so I'm just ignoring everything that is not a node on here. I try to figure out the row and column of the button that gets pressed, and then I have two handlers. And the important one is the node on handler, and that one going to copy over. That's a little bit more complicated because it does a lot of different things, but one thing it does, and that's like where functionality goes in, is this part. So there's a click square function in the original. Like the original looks like this. This is really old school JavaScript. And there's a, where is it? Like this is the full Minesweeper implementation. There's this click square thing that's just an event handler that's on every element on the web page. And I'm just calling that from my function to be able to not having to monkey patch the other software. And so basically I'm clicking the square. So this should now actually work, I think. Did I? Yeah. So let's load this again. And now, so you see that I hit the button. Nothing is displayed because we didn't handle that yet, but you can see that I can already expose fields. So that's cool. You know, all I do here is I take the row and column, and then the way the original game handles the internal data is just using 64 length arrays, and you know, basically every row is 8 bytes of that, or 8 pieces of that, and so to get the actual position, you just take the row, multiply it by 8, and then add the column. And the important part is this one. This is a normal click. Exactly. And then let's try to get display on, and that's a little bit more complicated because again, I didn't want to really patch around in the other thing, and I did a very stupid thing, which is just overwrite the function. It's a bit pointless probably, and that's basically the longest function. It's a little bit hard to go through that, but we're trying. It basically mirrors the original setSquare function, and instead of setting classes and changing the contents of cells, it sends MIDI notes. And if I do that, actually, nothing happens. Yay, why is that? That is a bummer. Ah, okay, that's a help function I wrote that needs to go in there as well. Oh, God. So that's just, you know, going from the, yeah, exactly. So this is, I showed you the documentation, and I just tried to figure out some color values that make sense, and I'm just using just adding the velocity values here, so I need to put that in here as well. There you have it. And you can already see like the yellow tones, something may have to do with the lighting in this room, but they kind of look all different even though I'm sending the same value to all fields, so that's kind of a bummer, but yeah, great. But you can now start playing the game, which is kind of fun. But for example, what we didn't handle, did we? No, what we didn't handle yet is flagging, for example. That was obvious. So let's do that. Where was I? So, like, I mean, looking at this doesn't even make sense if you don't know what the original code does, but you have an array which gives you the exposed elements, and then there's another array which gives you the adjacent values, and you basically go through all the possibilities and then set the right color. So exactly. So in this case here, I'm checking on the node on handler. I'm checking that the column the button was pressed on is smaller than 8 because the 8th column is like my command column, and so I have this other thing here. If it's row 6, that's the G. Oh, you don't see they're actually letters next to it. It's the yellow one. This basically resets the playing field. And click smiley was like, that's a bit weird, but that's how the original game works as well, right? And that's a function in the original implementation. So the other one is row 7. I'm just toggling the flag mode and then sending a node to it so that you actually see this blinking, right? So I can toggle flag mode. Oh, come on. Give me something to work with here. And I can now switch this on and flag it, switch it off again, and play on. So that's pretty obviously a mine. Do you agree? So that works. And now let's do the last thing, which is a way to show how many adjacent buttons are there. And that's the fun part. These are just two functions. Going to copy over as well. And what this does is it sends control changes because for some reason the row on the top here is switched on and off by control changes. And I'm just going through the adjacent, the number of adjacent fields here and switch on this top row so that if you hit the button, you can actually see how many mines are adjacent to it. So well, of course I need to, and just a function to deactivate that display as well. That's that one, and then where's the off handler? I didn't include that. So now you know my code better than me. MIDI's, come on. Yeah. Exactly, let's include that one as well. Somewhere, just throw it in there, it's totally irrelevant. And then I need to activate it here. And now it's basically done. If I, for example, hit this button, you see that there's only one mine. So I can flag this one, and since this is also one, I can also flag this one. This is also one. You know how to play Minesweeper, right? And one thing, like how late is it? Oh, we're almost done. Okay, so these are now about 160 lines of code of relatively well commented code. I'm pretty sure I could write it in a more compact fashion, but then you wouldn't understand a thing. It's actually online at half-byte GitHub. Minesweeper, there it is. So if you have a launchpad, which you probably haven't, you can actually play it there, but you can actually also just play it on the screen. Credits to Andrew D. Birrell, who wrote the original implementation, probably in, I don't know, 1995 or something. And for me, it was really fun to just try to figure out how to hack this in there without actually touching the other code. As you can see, it's relatively simple to just send MIDI data over here. And now I'm going to show you one last thing, and that is the implementation from this morning, which is just an array. And I know it's hard to see, but this is the J and this is the S. And then I'm just sending out, I'm just activating the output, and then I'm just sending out this array very, very simply by copying over some code. And if I activate that, you get the logo. So, so what can we do with that apart from playing Minesweeper? And I'm going to sit outside. If you want to play it on the launchpad, I think it's a pretty cool experience. Just come over and hit me up on that. If you want to, what can we do with that? One thing that I find pretty cool is that Atom, my editor, is actually building on Chromium, and I think the WebMIDI API works there. So what about using this for some additional keyboard shortcuts? I mean, there are 64 plus 16 on these. Or display test results from your unit test runs or something, and then you can just hit a red button and go to the file and position of where the error is. Stuff like that. It doesn't make a lot of sense, but it's actually pretty fun to play with. And MIDI communications is so fast that it doesn't even matter if you, Atom is already not so fast, but probably that doesn't matter as much. So thank you very much for listening. If you have any questions, like I said, I'll be sitting outside. Thank you.